Hello guys, in this video we're going to be looking at simultaneous equations and particularly the substitution method. So we have 2x plus 3y is equal to 14 and x plus 2y is equal to 8. I'm going to label this equation number 1 and this one equation number 2. So we use a substitution method when one of the equations contains a unit quantity of one of the unknowns, such as what we have in equation number 2. This x right here is what we are talking about. So the first step would be to write x in terms of y from equation number 2, and that would give us x is equal to 8 minus 2y, and this becomes my equation number 3. I'll then go ahead and substitute this expression for x into equation number 1. So that gives us 2x minus 2y plus 3y is equal to 14. And then we solve for y and we get 16 minus 4y plus 3y is equal to 14. And then we group like terms. 16 minus 14, we get 2 is equal to 4 minus 3, that is 1y, which is the same as y. So we get our y as equal to 2. And then we come and substitute into equation number 3 because we already have y, and that would give us x is equal to 8 minus 2, substitute y for 2. So that is 8 minus 4, and we get 4. So the two values that we have or that we get for x and y are 4 and y is equal to 2. So that is how we use the substitution method. I'm going to look at 2 more examples of how to use the substitution method. So example number 2, we have 4x plus y is equal to 14 and x plus 5y is equal to 13. I'll label this equation number 1 and this equation number 2. And I will take equation number 2 and say x is equal to 13 minus 5y, and this becomes my equation number 3. Then I substitute equation number 3 into equation number 1. So we're saying equation 3 into equation number 1, and we get 4. Where we have x, we say 13 minus 5y plus y is equal to 14. 4 times 13, we get 52 minus 4 times 5, that's 20y plus y is equal to 14. We then group like terms, and we have 52 minus 14, we get 38 is equal to 20 minus 1, that's 19y. So you divide both sides by 19, and we get y is equal to 2. Now, we substitute y into equation number 3, and we have x is equal to 13 minus 5y, which is 13 minus 5 times 2, that is 13 minus 10, and we get 3 as the final answer. So the two solutions that we want are x is equal to 3 and y is equal to 2. And example number 2, a plus 4b is equal to 6 and 8b minus a is equal to minus 3. So I'm going to label this equation number 1 and this is equation number 2. And I will start with equation number 1, where we get a is equal to 6 minus 4b, and this becomes my equation number 3. So now substituting 3 into 2, we get 8b minus a, that is the same as 1a, right? So we get 1. 6 minus 4b is equal to minus 3. we get 8b minus 6 plus 4b is equal to negative 3. 8b plus 4b, that's 12. B is equal to 6 minus 3, that is 3. You divide both sides by 12 and we get b is equal to 3 over 12 or 1 over 4. Then we substitute b into equation number 3. So we always use the third equation that we would have created. So that gives us a is equal to 6 minus 4 multiplied by a quarter. And we get 6 minus 1, which is equal to 5. So the two solutions that we want are a is equal to 5 and b is equal to a quarter. So that is it, guys. That is how you deal with simultaneous equations using the substitution method. So remember what I said at the very beginning. You use the substitution method when one equation contains a unit quantity of one of the unknowns. So I'll just go ahead in our examples, pointing out the unit quantities. So you can see that we had an a here and we also had an a, right? And then in the previous example, we had x and we had y. So these are the unit quantities. It becomes easier to substitute when we have unit quantities like this. And in our very first example, we had x right here. So we could make x the subject of the formula and we then substitute. That is how you deal with simultaneous equations. See you in the next video.